So for 180 degrees conduction, what we need to do is that we assign our first switch to conduct for 180 degrees and off. Then it will appear again here to the cycles of the continuing cycles. But you don't have to draw here because it's just stop here. Just draw the tail and just like that. And for S2, we have to note that it will start after 60 degrees gap from the S1. So it means that it will start here and continues to the next 60 cycles after the S1 stop. And then S3 start after 60 degrees of gap also, and end after 3 blocks. So you refer or you use the blocks as reference. So we make 6 blocks. 1, 2, 3, 4, 5, 6 here. So this 6 block as our reference. Each block represents 60 degrees. So for S3, it starts here and end here. S4, S5 here and here by right. So S6 starts here and end here. So you can see that it conducts for 3 blocks. It blanks for another 3 blocks. And it starts to conduct again. You don't have to fill in it's up to you. So it conducts for 3 blocks. It blanks for another 3 blocks here. So we have a blank of 3. Conducting of 3 blocks and blank. So you have here 3 blank and 3 conduction. So 3 conduction, another 3 blank. So 50% conduction, but with 180 degrees of mode of conduction. Same to S6. Okay, let's say we are having this is for 180 degrees. Let's say if we are conducting for 120 degrees. So for 120 degrees, let's see we have here 1, 2, 3, 4, like that. So actually the sequence or the pattern is the same, but the conduction is only 120 degrees. So we have here 60 degree plus 60 plus 60. So total is 180. But for 120 degrees, so the conduction will be like this: 1, switch 1, 120 degrees and off. And then for switch number 2, it starts after 60 degrees gap and 120 degrees. Switch number 3, like that. Switch number 4, like that, 120 degrees. So it starts again to conduct on another cycles. Means that if we have only one cycle here, so it's just end here lah. Okay, but if we have here another graph charts for another cycles, which is the second cycles, so it starts again after 2 pi. So this is pi. So 120 degrees, complete one cycle, start again on another cycle. Okay, so you can see only one pattern or one pass on one cycle. But the most important is that you have to take note that only starts after gap of 60 degrees after the first cycles. 1, 2, 3, all gap in terms of 60 degrees next to each other. Okay, so we go back to the 180 degrees discussion. So we go back to the circuit and the sequence getting that we have chart. Actually here we have another blocks, because as we know, we switching on 3 blocks of another 3 blocks. So we have switching on 3 blocks, so should here will be another block of switching. 3 blocks of switching, 3 blocks of blank, off, on and off. Okay, means that on the we have a sequence of number 1, 2, 3, 4, 5, 6 mode. So for mode 1, we can see from here that the switching branch is 1, 5 and 6. So 1, 5 and 6 are on. So means that the current are flowing from source coming into 1, going out into 6, and as well as going to the 5. But seems that 5 is the source, so it's not going on anywhere. So the most meaningful is that from source going to A, so this is A, B, C, going up through B and back to ground. So if we chart or we draw again in terms of the simplified circuit, sorry, it enters from 2 here. It enters from 1 and also enters from 5. From 5 it enters through C and going to 6. Means that it enters from A and also from C. From A and C. So this is 1. This is branch number 5. So enters from A and enters from C, go out to B. So from A and C going to B. So we have here VAN is equal to VCN, which is V across the branch here. Meanwhile, we have another branch of VBN. Okay, we shall calculate these two based on the Ohm's law. Ohm's law of V equal to IR here. So first we find out what is the total R equivalent that across the load here of composition of load A, B, C here, which we assume as equal resistance of R. So R equivalent is equal to the branch of the above here, A and branch C, plus branch B, which is R divided by 2 for A and C, plus B of R. So we have here R over 2 plus 2R over 2. So we have 3R over 2 in terms of equivalent resistance. In terms of I, we shall divide V source divided by equivalent resistance of Vs divided by R equivalent of 3 of 2R. 3 divided by Vs divided by 3 divided by 2R. So R2 will be shift to above. So we have 2 over 3 Vs over R. So this is the value of I that flows from above to the ground, or from the source to the ground. Okay, then for VCN, we know that VAN, V across the branch A and C is the same voltage drop, equal to I, total I, that crossing the circuit, times the resistance of the mix between A and C. So we have 2 over 3 Vs per R times R divided by 2. So we cancel out R, cancel out 2, we have Vs divided by 3. So 1/3 of voltage source drop at this branch if we have pairing of resistance. So meanwhile VBN, so voltage drop is equal to 2/3 of Vs. So we have here 2/3 of Vs. So this is the voltage drop across VAN and voltage drop across VBN. So from this level of voltage drop, we shall chart the line to neutral voltage pattern. So actually the drawing you can draw with the source. So it goes to our resistor, pairing of resistor, and back to the source. So this settle for mode 1. So we have to solve for all the mode that available for this sequence, which is mode 1, 2, 3, 4, 5, and 6. So once we compose the mode, so we go to the charting of the line voltage, line to neutral voltage, and line to line voltage. So the sequence of our task is more like we are drawing the circuit, the three-phase circuit. Let's say we are drawing for 180 degrees just now. Then we go for switching pattern. For gating 1, 2, 3, 4, 5, 6. The sequence of our gating or switching pattern. Then we go for our mode. So the third step is our mode analysis, which is 1, 2, 3, 4, 5, 6, and it repeats after. This is completing the first cycle, then it repeats for another cycles. Then we go for voltage of line to neutral. So we have here VAN, VBN, VCN. Then we go for V line to line voltage. So we have here VAB, VBC, and we have here VCA. So this is the sequence. We draw the circuit, we get the switching pattern, we do mode analysis of each of the mode, and then we go for VE line to neutral analysis pattern. Then we go for line to line pattern. So the mode of analysis we just performed just now for mode 1, so we have to perform for mode 2, 3, 4, 5, and 6. Then only we are able to decide. Like just now, calculate. We know that when on mode 1, from the circuit, so we have pairing of here is A neutral. Just now this is it comes from A, C, it comes into A, C, go up to N, and return to B to the source. So we have charted that VAN is equal to VCN equal to 1/3 of V source, and meanwhile VBN, VBN is negative. You see here is positive, negative, so negative of 2/3 of V source. So from this value we transfer into the graph. So for VAN, we can see that is equal to VCN 1/3 of V source. VAN and VCN are the same, positive 1/3 of V source. Meanwhile for VBN, negative 2/3 of V source. For VBN, negative 2/3 of V source. So we chart it per mode of scenario. So we saw for mode 1, we again repeat for mode 2. So for mode 2, we can see that we have here S1, S2, and S5, S6, sorry. 1, 2.